Okay, hello everybody. Looks like we have a good group of people now. Yeah, so this is the Feast demo. I think it might say Tecton in the corner. I don't know if you guys see that too, but it is actually a Feast demo. Feast is an open source feature store, and Tecton is like a enterprise feature store. So my name's Jay. I actually work at Tecton, but I'm a maintainer at Feast, and so I spend all my time working on the Feast project. But they're related products for sure. Um, and so I'm gonna give a bit of a background on Feast, and then we're gonna do a quick demo where I'll jump in and show you guys how it works and some of the flows. But I think these type of events are the most valuable when you got like everyone's engaging and kind of asking their own questions and I'm answering them synchronously. So feel free to ask questions at any point in time, and I will I'll find a stopping point in the demo, and I will jump over to your questions and answer them. So I think that's probably the best way to do it. And just for people who can't find the chat, I was having a bit of a struggle. It's on the on the right hand side, and you have to put it in the session chat, not the event chat. That's for the whole event. Yeah, so I'm gonna share my screen, and we're gonna get started jumping into this demo, and I'll give you some background on Feast as well. I'm doing the entire screen share, which might be controversial because some stuff I might not want to show might show up. So apologies in advance for any gaffes that happen. I'm a big fan of gaffes personally. Cool. So what is Feast? Feast is a feature store, and it's really a product focused around solving some problems that occur when doing real production machine learning on real data. So I also know that I've been to some of these TMLS events, and there's quite a bit of people that are doing research. So I'll give a bit of background onto how is this different than research as well, if you guys are curious about it. But first of all, we help you serve your features in production. We help you build training data sets that are accurate and point in time correct. And we also help you share features across use cases and across models, which has been very valuable. And so the history of bit of history of the project: Feast was open sourced by Gojek. Gojek is this very large taxi scooter company from Southeast Asia. I wasn't aware of it before Feast, so I don't blame any of the North American folks if they haven't heard of it. But Gojek is like a Deca unicorn, and they started this project internally to share feature resources and solve the data problem at their company. They open sourced it so other people could use it. And Tecton, which is the company I work at, joined as one of the major contributors. And so now the creator of the project works at Tecton and contributes code. I work very closely with him. We have a team of engineers at Tecton that are just full time contributing to Feast and making Feast successful. And so we've seen quite a broad range of adoption in the project. I would say the project is the most busiest it's ever been right now. So there's some teams contributing up here, but there's way more teams than just this. And so I would encourage you guys to jump into our Slack. The link is here. The website's feast.dev, and also just jump into our GitHub and take a look at the people asking questions, making GitHub issues, because there's definitely quite a bit of activity and adoption around the project happening right now. Cool. So what does Feast actually do? I think that's an important question to answer. So Feast, I think the number one thing Feast does is it operationalizes features. So you have important distinction here. Actually, let me just jump back and see if anyone has any questions right now. Not yet. So important distinction is that in the real world, your data is changing all the time. So you're getting new time-stamped data into your system all the time. And so you have to deal with time in time is a very important thing to deal with. It's not actually something that you really see when you're kind of building models in the abstract or without a production use case. And so what we help people deal with real world timestamp transactional data, And so kind of first thing we do is we operationalize features that are living in in an offline environment. So if you make your features using, Python, you're loading it onto S3 or you're loading it onto a data warehouse, we will load those features into an online store. So they're available at low latency for models to get. So typically if you're just creating a bunch of features, they're not available at low latency for people to actually retrieve and make predictions based off of, models to make predictions off of in real time. So we enable that online prediction by just letting you load those into an online feature store. And we have the right data model for that, and you can declare your features in Python, and it will deal with all that materialization and stuff. And it's as simple as, so you don't need an engineer or anything to do this. It's really data scientists can actually load their own features into the online store to go serve in production. That's quite important. Now there's another piece that's sitting back here that produces the feature values. So you need a way to do that. And so Feast does not produce your feature values right now. It's not a transformation framework, and it's not an orchestration framework. We kind of just deal with the retrieval of features. So that's another thing that you might have to solve for. And we definitely have some recommendations and best practices around that. You can ask me more about that, and I'll chime in as to what kind of architectures we see, because Feast really fits into a stack. It's not just a one size fits all thing. It's not a platform. It's a tool that does a specific thing, and we're pluggable, so we'll fit into whatever stack you prefer. So that's one thing of operationalizing your features that are offline. The second thing we do is that we let you build training data sets that are historically correct. And so what this means is, typically you kind of just want your data eventually get into the situation where you have all your signals, all your features in a data frame, and then the label on the right as what you're predicting, right? Or it doesn't matter if it's on the right or left, but you need signals, you need features, and then you need labels. But where do those actually come from? They usually come from events that occurred in your system. So if you're predicting fraud, someone made a transaction, it turned out to be fraudulent or not, right? And so when you're making a prediction, you want to see what the features were as of that time in the past. I think there's a diagram I can show for this. I'll scroll to the diagram. Cool. So here's the diagram. So in this situation, we're trying to match a driver to a rider, or predict the outcome of a booking for a driver and rider. Imagine we're Uber. And so the prediction is made at a point in time, right? And all these features, the acceptance rate of a driver, the trips that a driver gives, average daily trips, they're computed at different granularities. They're changing, right? So we don't want the average daily trips of the next day. We want it of the day, the day that the trip happened. And then second of all, the prediction happens later, right? And so you can, if you give Feast time-stamped feature values, and you give it times or the event times, we'll build the data set. We'll do time travel for you, and we'll tell you what the features were as of this orange dot, and then you can join in this purple dot, and then you have a data set that is actually trainable. And so for people who have ever tried to solve this problem before, I have in my past life as a data scientist, it's usually a 300 to 500 line SQL file that does this kind of join, and Feast gives that to you for free in a way that's very easy to use. So it's another big benefit. So that's the offline case. And then kind of the other benefit is that if you define your feature in Feast and you use the offline path to train a model, and you read features in the online path from the online store, you're kind of guaranteeing that the same data was computed in the same way, or in the offline and the online case. And so you kind of get this train serve skew or lack of train serve skew for free by picking up Feast. And that's another really big thing we see teams value. At Tecton, we have this customer, Atlassian. Atlassian has great engineers, and before they adopted a feature store like Feast or Tecton, they found that they had 5% of values that were calculated differently in their offline and online cases, because there were two pipelines, right? There was one pipeline that data scientists use to train their model, and there was one that data engineers use to populate the online store. And so what Feast gives you is, just calculate your features once, load them into a data warehouse, and then we'll deal with putting them in both environments for you in a consistent way. And so that's kind of, and then, okay, and then on top of all of that, so here, I'll just make sure I've gone through all the problems. Consistent access, that's right. Deploying features, that's right. Point in time correct data for models, that's right. The last thing is feature reuse. So, if your friend made a feature that is actually very valuable for his model, Feast lets you pick up that same feature just by like making a reference to it. You don't have to go find the data asset or find the notebook that he used to compute it. It's just available in the feature store, so you can go read from it. And that's also very, very valuable. At Gojek, there were models that were created just based off of completely reused features. So you didn't have to go do any data work. You just, you found your labels, and then you just like use all the features, and then you had a new model, which would be amazing. I think I've done data munging. It's like most of the work in creating a new model. So that's problems Feast solves. Hopefully that's good background for you guys. I just got some questions. I will answer them. Amit asks, hey Jay, how does the dev prod promotion process look for features? Thank you. So that's a really great question, Amit. So Feast is actually pretty flexible in terms of like whatever governance workflows you want to integrate with Feast. So we've seen a bunch of different processes or best practices here. So there are you could like have a schema in your data warehouse. One is like dev, or each person have their own schema or data set, and they like do their work in their data set, their dev data set, and when it's ready, they'll like push that to the right data set in the data warehouse, and then they'll register it with Feast. Feast is also, which we're going to get to in a second, it's Git backed. So like the features in Feast, you define them as Python files, you register them in Git, and so when you're making a new feature, you can actually just like make a PR for a new feature, and then people can comment on it, and they can you can go back and forth, and you can discuss that, and then when it's ready, you can promote it to prod by landing that PR. So you can like branch out the repo, do some work locally, and then push it back to Feast by merging it back in. So that's very common practice we see, and I'll actually show you like what that would look like later in the demo. But great question. Great questions. Keep them coming. Lalit asks, do you do time travel and find missing data points? We do time travel, and missing data points is an interesting question. So I'll go back to the quick start very quickly, and we'll see some of this stuff later. But like imagine that like for some reason you put like a driver, like you're trying to like query for drivers features as of this time, but like for some reason you don't have the conversion rate. Like we didn't compute that, or like let's say we missed this day, right? So Feast will actually go and look back for the next day, and it'll grab that value, and it'll keep looking back until a threshold that you define. So like I will go to the threshold here. This is like a definition of a feature view. I'm skipping a bit above here, but this is a definition of a feature. And here we have a TTL. So this TTL defines how long the features live in the system before we just like consider them null. And so this one, I don't know how long this is. I think this is 1 day. Let's see, 1 day. Wow. So this is an hourly stats thing. So if this like is any less fresh than a day, we'll just give you a null instead. So you can imagine that here, this, let's say trips, whatever this acceptance rate, like if it was converted every hour, if you just don't have a number here, we'll get the next one. And then if you're missing all of them for a day, we'll just say, hey, this number is so invalid that we don't even want to give it to you. We're going to give you null instead. You control that threshold yourself. And then when you get that data frame out of Feast, you can check for those nulls, and you can fill them if you want. You can drop the rows if you want. And I'll show you like what that data frame looks like. So that's kind of how we think about nulls or missing data points for the offline case. So that's another great question. Borke asks, how does backfills work with Feast? How do backfill work with Feast? Any recommended architecture? Yes, another like very astute question. I think that one. Well, so I'll just give you the Cliff's notes, but that's a whole discussion for sure. So Feast is pretty ambivalent to your to the way you compute features, right? because we just deal with retrieval. And so you just like point us to a data source and we'll help build the data sets and we'll load that into prod. And so you actually like need another component that will like compute that data for you. And that's where you would like implement your backfills. Now, there are like a bunch of recommended ways that we like think that you should do backfills. And there's this tutorial that is coming out very soon. It's a fraud prediction tutorial. This is like a draft right now, so it's not available for people to see, where we will show you how to backfill feature data. And it's not really complicated. It's not crazy complicated. I will actually just show you, I'll just tell you how it's done, and then, hopefully that's informative. But again, we're completely ambivalent to whatever way you want to create your backfills. So in this example we give you, basically what we do is we create a query that does an aggregation, right, as of a start point and an end point on some events. And then we just run that query as of a bunch of times in the past. And so we kick off that query 10 times and you'll have features for every single 10 days in the past. And so that what that actually requires you to have is an event stream, or like a list of events that happen, so you can do those aggregations in the past. If you're like updating your tables in place and you don't have events, then it's almost impossible to backfill. So we kind of recommend you like have this event driven architecture. I will show you what that looks like as well, just very quickly. This is like kind of what the raw data looks like. So it's like if these were transaction events, because it's a fraud data set, there's a source, account, amount, destination, and a timestamp. And so like these are just like a huge log of all these events. And so you can imagine I can do like an aggregation as of a time in the past because I have these like events sitting in my system. So that's an example of how you can do backfill, but Feast doesn't really care how you do it. We're pretty like, we don't really like, it's not that we don't care, but you know what I mean? Like we're very flexible to whatever implementation you choose there. Last question from Olit. My curiosity was with respect to unequal interval for time series data, which could be problematic if you were defining RNNs/LSTMs. Yeah, this one is a very meaty question of like how we deal with time series data. I'd just say right now, there are ways to do that. There's an issue I'll link you to, but it's not like a first class flow. But we do have issues where we discuss that on GitHub. So I will throw that in the chat after. Focus Neo says Feast does not support labels. Documentation says we need to join with external systems. And so what I would say here is labels typically come from the event. Like they're not like an attribute of, so you can register your labels as a feature, like that is possible. Which is like in most cases, and you'll actually see the use case here that like it actually makes sense, a lot more sense typically to make for the join to happen outside of Feast. Now, in terms of external systems, what I will point out very quickly before I'll just like cut to the chase and jump into the quick start because we've been doing questions for a while, is Feast isn't like a monolithic system you like install on your computer on your cloud and will store data inside Feast. We actually just like orchestrate data flows from your systems, right? So if you have a data warehouse, if you have files on S3, you have a Firestore, Dynamo, or Redis instance yourself. We orchestrate data between those. And so all the data you're reading in Feast already lives on your data warehouse. So it's not actually like a super onerous thing to just make a join between data in Feast and data outside of Feast, because it's all on the data warehouse anyways. And so Feast, what was the point of Feast? It wasn't to like innovate on offline storage. It was actually just to make sure that these workflows where you're able to do these things so you can put ML apps into production easier. So we don't actually manage an offline store or anything. We just deal with whatever you have already. So that's like a very important distinction. And I think there was one more question about batch and streaming features. That is like a larger topic, so I'm going to keep that to the end, but we'll definitely have time to talk about that at the end of the session. Okay, so I'm going to jump into the quick start. That was what we're going to go through today. And you can actually read this yourself, but I'm going to like walk through these flows. And if you have any questions about them, you can ask them and we can answer on this session. And I'll like also give you some insight or explain like what we're doing a bit more, because the quick start is like kind of very hello world. And just by the way, the reason why it's so hello world is we wanted like an extra tutorial that was like end to end, that was a bit longer and kind of explains how a stack works together. And that is the purpose of this fraud tutorial, which is just in draft. It's going to get out in the next couple of days. Okay, the quick start, like I'll walk through this with you guys. Obviously, you have to use multiple environments to do the quick start. It's not just one. So I have my terminal here. I'll open up a code editor as well, and then we have the quick start in this. So first thing is to install Feast. I already have Feast, so I'm just going to write Feast version, and we're going to see what we have. So Feast comes as a Python package, and then when you install the Python package, you also get a CLI. You get a CLI as well, so you can run Feast commands. So I can see like Feast-help, I think. Feast-help. But yeah, so this would tell me all the commands I can use. And these are all just like managing features. So I'm gonna clear my command line. And so the first thing we do is we register features to Feast. Now, if you're getting Feast set up in your system, the first thing you would do is actually make the features like yourself. But this is like assuming we already have some features generated. How do we get Feast set up? And you might have some features set up if you already like trained a model or whatever. But this is kind of like bootstrapping the Feast installation, or like the Feast deployment. So kind of creating a new feature repo with Feast init. It creates some general files for me. So I can I'll see feature repo, run this tree command. You can see it comes with this Feast init, comes with some sample data. It comes with an example file. It comes with this feature store.yaml file. So I'm just going to like take a look at each of these quickly so you guys can see what each of them are. And just as just so I can explain where we are right now, this is a feature repository. So when you have a feature store.yaml, it defines a feature repository. And then when you want to define a new feature, you'll put the definition in the feature repository. You put it in that folder. And then Feast will read all the files in that folder and like kind of those are your definitions. So it's like Terraform if any of you have used that. And so it's kind of different than like a Jupyter notebook where you would like, if you're creating stuff in MLflow, I think you just like run MLflow commands in a notebook. We're a bit different just because we think it's very valuable to have a state of truth. So you can always look at the Git repo and see exactly what's in Feast. Which is like not the case with every tool. So we recommend that you check this into a Git repo. So this would be like the base and you check this in and then you'd have like a Git repo that like defines all your features. And so I'll look at these files very quickly for you guys. The feature store.yaml file defines how the feature store runs. And so right now we have the most important thing here, besides these are metadata options, the most important thing is the provider, which defines the environment that the feature store runs. So I have local right now. We also have GCP, which would spin up all these resources on your cloud, and that would be like ready for production. Local is more for testing. We're going to do the local flow today, but my tutorial goes over the GCP flow. We support it's not just tied to GCP. We just chose to ship GCP first. We had this like big refactor recently. It wasn't super big, but it definitely did change some stuff up. And for those reasons, we just shipped GCP right now, but AWS is going to come in like a couple weeks. Someone's working on it right now. And then you can also build your own custom providers, it's really not that much work. So you can actually leverage your own infrastructure if you're on-prem or whatever, by building your own provider. Several teams have already built their own providers. So there's like some knowledge about that. And we have this RFC out right now that kind of explains exactly what the provider model is. That's going to trickle down to like a documentation page where you can read about how you can implement your own provider. So this is the feature store.yaml file. It's kind of like how we deal with your infrastructure and your environment. And so I could change this to GCP and then go from there. But right now we're doing local. And so what does Feast contain? It contains a registry which just stores the state of all the features, like tells the clients how to read the features and stuff. Then there's an online store, which in the local mode it's SQLite, in GCP it's data store, and we're gonna have Redis soon, and then on AWS it'd be Dynamo and Redis and whatnot. And then there's an offline store, and so we also just use Parquet file. Or there's an offline store that we'll like deal with. Again, we don't maintain any of these things specifically. Like we don't like, you know, like Feast doesn't come with a Redis deployment. You'd spin up your own Redis deployment. But we also, there's all offline store as well. On local, that's Parquet files. And you can actually see we have some Parquet files here. So I know there's going to be some questions, or I think so. So I'm going to pause here. And it doesn't seem like there is anything yet. So I'm going to keep going. But if you do, just throw them in there. So this is the file that defines how the feature store runs. This one is a definition file of some feature definitions. And so you can imagine if you had like a lot of features, you might have multiple, like many files, you might have folders and stuff, but we just have one file in our example, feature definitions. So this just basically is like a pointer to a data source. This could be BigQuery or anything. This is creating an entity. So at Feast is a feature store, and we manage features that are about entities. And so this entity is based on drivers. So it has the driver ID name, and we'll join features about drivers onto like a data thing based on it. It's also very important. It's a very useful thing for curation. So when the feature repo gets larger, you might want to search, okay, I'm trying to predict churn. Churn is like users churn. So I just need a bunch of user features. And so you can like search the feature repo for all the features that include like your user entity. So that's actually also another valuable thing there. So you just have to create the entity very quickly. It's just a metadata field basically. And then finally we have a feature view. So what it is some information about the features, some information about metadata like entities, some information about what Feast should do with it. So this one has online equals true, which means that we should load it into the online store when we apply this to Feast. And then it has like some information about how Feast should read it, like I guess the input, which was this pointer to the data we saw before, and then also the TTL, which we talked about before, which defines how stale the data can be before we'll just give you a null, which is like important for like correctness and stuff. So this is like what a feature definition looks like. And when you make more features, you would just make more of these feature view objects, and you organize them in different files and different folders based on how your organization prefers to do that. Cool. So that is a feature definition. How do you use a feature definition? You have to apply it to Feast. So Feast doesn't, just because you wrote this, Feast isn't aware of it. So every time you make a change, you want to run Feast apply. And what that'll do is it will push all of your changes to like a local state, like a database that contains the things. And Feast actually just uses like a little blob in an object store to do that, so it's not like very heavyweight. In local, we'll just write that to like a registry.db file here. But in production, you'd want to write that to like a cloud storage bucket or a S3 bucket, so you can read it from your client. So you don't. It's not just local. So this is like just local flow. We put it here so we can read from it locally. And now Feast knows about our new feature. So now we can use it with Feast. But you'd have to, every time you make a new feature, you'd have to make a new definition. Amit asks, is there a UI for feature discovery and maybe some access control on who can access certain features? Another great question. So UI is on the midterm roadmap, but not right now. One benefit of having a repository is that it serves probably around 80% of discovery use cases, because all the features are in a repository somewhere in a central location. And so if you need to like discover a new feature, you can actually just clone the repo or use GitHub, and then just like search with whatever ID you have or grep to find the features that you're interested in. Obviously not as great as having a UI, but that's just on the roadmap for scope reasons. And we've seen people run this at scale, have like hundreds or thousands of features in year, and it's not been a blocker just yet. So definitely like something we're looking at though. Access controls. Feast is like, I think our kind of stance on access controls is that we don't support them right now. We do want to build like hooks, so you can build your own authentication like thing, and go check if someone has the access controls to read a feature. Just don't have that right now. Recommended way to do that is either just for like if you had role-based authentication, you can actually just have different feature repos, and some people can have access to some, and you can restrict that internally. And if it's okay for everyone to see the features, but only some people should be able to read them, you should actually just put them in tables that the people like, because we're just reading on your BigQuery or your S3 table or your S3 or whatever, or your Snowflake or Redshift. You can put access in that, and then that would enforce who can actually make those reads happen. But the metadata would all be the fees. So hopefully that makes sense. But we're not. It's just like a scoping thing. We don't have like a huge staff to run the project just yet. And this is like a highly requested feature, so there are issues documenting what we're thinking for them. Okay, cool. I'm gonna jump back to the thing. So we've defined our feature. Now we want to generate training data based on those features and some events. So these, we just did those workflows in a CLI and in a feature repo, but these interactive workflows where you're like training a model are best done in a Jupyter notebook. But you can also do them in like a Python script, but I'm going to use a Jupyter notebook. So let's create a new Jupyter notebook here. I just found out about this feature recently in VS Code. It's pretty amazing to me. I don't know if you guys find it amazing, but they have like your own Jupyter notebook, so you don't have to go spin up like a Jupyter server. VS Code will just do it for you, which is pretty great. So I'm going to import these to check what the version is. Sometimes I have environment issues here. So this is an old version. I think there may be a problem with what kernel I have selected. Let's see if I can find the right one. I feel like everyone has gone through this problem at one point, Anaconda hell and whatnot. So hopefully you guys feel for me there. But this looks like the right version. So that's great. So I'm going to copy and paste this code. This is essentially like imagining we're grabbing this stuff from our upstream system. This basically says, hey, this driver took a ride at this event, right? And you can imagine that there would also be a label here too. We just didn't have one. We don't have one because it's a quick start. So like driver, ride timestamp, and like ride was successful or whatever. That might be like the data you get from your upstream system. Usually we see people just have like a table of these events. So it's like a select star from table or something, but it can vary, quite heavily depending on your company. Maybe you have to do like a bunch of joins to get this table, but this is like an entity data frame. So this tells Feast what times and what features we want to grab, what times and what entities we want to grab features for. And so if we had labels too, then we use this to get all our features, and then the labels would be there so we can train a model. So I'm going to show you how Feast does that. It's this code here. We're going to walk through this code. The other one is just like pandas. So what this does is first we instantiate a feature store class. That's basically just like the Feast client. And then we call get historical features. We pass in our entity data frame, which is this thing above. And then we pass in the features we want. So these are all the features we just defined in our last file. And what Feast does then is it looks up, hey, for this driver at this time, what were the features for these hourly stats features? And it'll just give us that back in a data frame. And so if I run this, you'll see that we have driver, right? We have all these features as of that time in the past for that driver. And so if you were training a model, what you would do is you would drop these two rows, or you'd first join on your labels, drop these two rows, then you have these three as your X, and then you'd have like your labels as your Y. And then you could just like, do a model.fit or whatever you want there. So hopefully that workflow kind of makes sense to you folks. And that's kind of like how you would get offline training data. It's actually hopefully very simple, but it can be very complicated if you don't have like the right APIs for it. Some pause there, look at questions. Doesn't look like there are any just yet, so keep them coming if you do have any. Cool. So let's say you trained a model based on your features, and now you want to like serve those features in production and make online predictions based on it. Feast isn't like, we never loaded data into the offline store. So you can imagine that like maybe that training data that we generated is actually huge, and so and you also want to like you need to update this on like a rolling basis, right? So like as new features are getting calculated, you need to like materialize data to the online store often. Like if I go back to the diagram here, sorry, yeah. So this materialize command is actually what pushes the data. So we haven't done that yet. So we need to run materialize. And what that'll do is Feast will go look for the relevant data in your offline store, and it'll push it to the online store. And this is all running locally, so the offline store is Parquet. Online store is going to be like a SQLite database. So it's nothing super complicated. And we have a couple of options for materializing. Some people just like want to run some shell commands in like in a Docker container. So you can run these commands at the terminal. I'm just like materializing a feature. You can see how many rows did we write. We wrote 5 rows. So we're running at scale here, but so we materialize data from this interval. There are 5 rows, and we're done. Usually it takes a lot longer than just a second to like materialize rows. This is the quick start. And we also have these commands available on the feature store object if you need to like just run a Python script on a scheduled basis instead. So it's not just like a CLI. Cool. So now we have the data in the online store, and so we can actually make real-time predictions based on it, or like we can fetch features in real time. So this command does that. We'll walk through this code as well. This is best run from a Jupyter notebook, but you can put this in your model serving endpoint, like as a custom prediction routine. You can also do this from like client services as well, or you can like put it in a cloud function. Like this is the same code you'd use there. So we're instantiating our feature store again, and then we're using get online features. We're passing in the same feature references, and then instead of giving a timestamp, we just give the entity keys, and that's it. Because we don't actually care about the historical values. We're making a prediction right now. We're making an inference. We're doing inference right now. So we don't actually care about the historical data, right? So we don't need to pass a timestamp. So if I run this, it will tell me the features for this driver, not as of the past, but as of now. And so you could pass these numbers into your model, and we trained our model on 3 inputs. Now in prediction, 3 inputs as well. So now you can run model.predict on these, and you get your online prediction that you can use in your application. And so that's that. Like that's kind of like the main flows of Feast, and that's like what it does, and some background on like how it's used. And so hopefully that's very helpful. That's helpful for you guys. I'm gonna jump back to the questions, and we can kind of have a discussion there. If other people are curious about some of these production architectures, we can also take a look at the tutorial very quickly. I won't run through the code there, but we can actually take a look at the architecture, and I can discuss some of that with you guys. Cool. So Amit says, do we always need an offline and online store? That's a good question. So if you're just, if you, let's see. So if you don't want to store your data, if you don't want to pre-materialize your data, then you don't actually need an offline store. You can actually just give us, in the feature definition, you can actually just give us this file source. There's a BigQuery source, right? Like BigQuery source, and then if I did this, I think here it is table ref. This is actually, it can be a SQL query, and so we would actually just run that SQL query when we wanted to retrieve data to materialize to the online store, and then you wouldn't have to like pre-materialize it. But definitely you need a place to like store the data, or like you wouldn't be able to build a model, or if that makes sense, unless you like hopefully that does make sense. Second of all, do we need an online store? You don't need an online store if you're just using Feast for the historical retrieval. That was one of the main reasons why we kind of shifted to this more modular thing, because you can actually just pick up Feast today if your tables are in the right format and build training data sets based on it. Obviously, you can't serve those features in production if you're just using the offline thing, but I think it's still very valuable functionality that way. So, if you're just batch only, you can actually just use the what was the command here? Batch only. You can use the get historical features with like this entity data frame kind of controls what we're fetching features for. If you pass the entity timestamp as like datetime.now, you'd get all the latest feature values, and you can run inference on that as well, right? You can just run inference and batch on the same API. So that's also a possibility. You don't need an online store. We actually do not. And if you actually, I believe if you take it out of the feature store.yaml, like I think if you put like none or something, there's like a flag, we actually just won't spin up any infrastructure. So good question, not always needed. Then Focus Neo asks, how often can we realistically materialize new data to the online store? What are you seeing as use cases that are possible today? So in batch, we do see some people do as often as every hour, every half an hour. That's very common. I think it really depends on like how much you want to stretch it. Like I think we probably could do 10 minutes or 5 minutes. I think 1 minute would be like definitely pushing it, depending on your data volumes, obviously. The use case for materializing new data at that low latency is streams. So I think someone asked a question about streams before. Feast 0.9, one of the main benefits was that you could define streaming data sources. So batch data sources, we would pick up your backfills or your historical data, and then like on an ongoing basis, we'd read data off of a stream and populate the online store based on it. So Feast 0.10 does not have that at the moment. We do not support streams. That was just for scoping. I think like if the main point of the Feast, if you're curious more about that 0.10 release, which came out relatively recently, you can look at this launch blog post here. I'll post it in the chat, and you guys can start it to read it later. But 10 blog post kind of explains why we did why we made these changes in the first place. Now, we are definitely bringing back streams very soon. I think we're bringing back an API very soon, and basically how that would work is you define your features, you define your batch source, and then you also just define a streaming source, and then on an ongoing basis, we'll spin up a job that lives somewhere, or we'll spin up a job that lives somewhere that will just constantly sync those new data into your online store. So if you do need like very low latency, the answer is going to be always streams, I think. Yes, so that is streams. What are the recommended patterns, I think, were some questions that someone else asked about streams before. And so what we recommend is that the recommended pattern from Feast is you have some features that are in batch, right? And you have some features that are streamed, but you always keep the batch data source as a historical log of the feature values that came on the stream. So that historical log is always available for when you want to like build a training data set. So Feast doesn't manage writing, like Feast does not manage at the moment writing from the stream into like an offline table. So you'd have to like also have a job that just writes that every so often to an offline table. But that's generally the pattern. We really think that you should have like kind of a source of truth for the stream, since it doesn't always live in the stream. Like you don't have infinite retention or anything, or that's just not that common. That's what we see as like kind of the pattern. So hopefully that makes sense of using batch and streaming sources together. Cool. And Giacomo asks, it would be great if you could help us understand how Feast fits into the larger infrastructure. Giacomo, you do understand well that Feast does the serving, but not the computation. So what are the best practices around computing, tracking the code that computes them, and storing them in the warehouse so they play well with Feast? So that is kind of the theme of this tutorial here. I'm just going to run to the top. I will just show you guys the diagrams, and then I'll talk a bit about what the system looks like. This is an example system, so you can use so many other options than what I have here. But this is an example of what an end-to-end flow would look like using Feast. So you have some offline raw data in BigQuery. That was like so I'll just show you that real quick. If I go to creating features, this is like what your offline data would look like. It's very simple, like some events or whatever. So that's offline data in BigQuery. Then you have feature compute, which is SQL. So this, like, I think if you're running this at scale, the answer is probably going to be Airflow or DBT. So DBT is like a framework. So, I mean, if you guys are not familiar with that, Airflow here is like kind of a DAG system. You can like build these pipelines that'll run. And then DBT, which isn't always like that. It isn't always that like common for people to know. Open source. Let's see if we can find it. It helps you transform data in your warehouse. So, wow, this is like a lot of doesn't really tell you what the product does. So it basically helps you transform data on your warehouse. And so very similar to Feast, you like define some stuff that lives in like a Git repo, and it'll transform tables according to that. So this is like another thing that we see people to like actually manage the tables on their data warehouse. So either Airflow or DBT. In our tutorial here, we just have like a SQL script that is scheduled. So it's not like production ready or anything, or it is production ready in the sense that you can actually use it, but it won't necessarily scale because this is kind of like a bare bones tutorial. So recommendations include Airflow and DBT for the feature compute. Next thing is offline features living in BigQuery, and all you got to do is for the offline features is to conform to the schema that Feast expects, which we've kind of seen before, of just having feature value or entities, feature value, and then timestamps. That's just so we know how to like read your data. Then in the training model thing, nothing crazy here. You'll build the training data set from the offline features using the same API we just saw, train your model, and then you have like a model, trained a model. Then to materialize features, again, nothing crazy as well. We're just doing the materialization flow we saw before. Obviously, this tutorial assumes you're running it on GCP, so instead of running it in SQLite, it'll be a data store thing. So that's actually available to fetch in production by like another consumer. Then finally, on the client real time, it uses get online features to get the features. Then you can deploy your model from your model training, like your notebook, to model inference. Here we have AI platform. It can actually be anything you want. It can be Seldon. It can be SageMaker. It can be anything. But you get your online features. You pass them to the model inference service. Then you have your real-time prediction, which you can serve to consumers. Also, entirely possible to just put the online features request in the model inference thing. So you just the client just sends a request to the inference thing, and the model inference endpoint will just grab the features from Feast itself. That's also totally possible. We've seen people do that as well. So this is kind of like what an end-to-end system looks like. I think the most meaty thing here is definitely the feature compute. And so we can like dig into even how backfills would work, or one way you could do backfills if you guys are curious. But this is like how we think of an end-to-end system. And this tutorial will actually walk you through how to do each of those things in production, like in a production ready way, not necessarily the way that will scale the best, but like a way that you can get something set up. Burkay asks, who do you see as the users of Feast in terms of their role? 1, data scientists, or 2, ML engineers, or ML platform/data engineers. So I think there are basically 2 groups of people who use Feast. The first are ML platform teams who want to like create tooling for people to like put features in production more easily. Those teams don't run ML themselves. They're just like primarily tooling teams. And so we've seen like large company platform teams like Shopify, Robinhood, other teams that I'm not going to mention by name, but like they're very large platform teams pick up Feast as like kind of their core of their system. We have also seen, and the other team that we see are just like practitioners that are hoping to set up a model in production making online inference, right? So they don't want to have to deal with the pipelines that bring data from offline to online, or have to deal with train serve skew, or like, you know, mitigating that. They just want to get something up in production. So it's really like they're not really like dealing with like that much repeatable work. It's more just like hey, I want to get this one up in production. Maybe I want to get my second one up in production after, but like I'm not dealing with like hundreds or thousands. And so two different kind of personas there. In terms of like data scientists versus data engineers, we actually put a lot of effort into making Feast available for data scientists to use. So you notice like during that whole flow, if you have AWS permissions, you can just go. There's no Kubernetes. There's no like Spark. You don't have to manage a Spark cluster or anything. So that's like another big benefit of using Feast, is that data scientists can actually do this. And so, you know, data scientists can get you all the way. We can get data scientists all the way to like having a model, or like a cloud function or something, like a Lambda function that you can ping and you'll get predictions back in real time. And that's backed by like real data that will update on a regular basis. So it's like a real production deployment. Well, you can get all the way there, a data scientist can, using Feast, because all the tools that data scientists know how to use, like pandas and stuff in batch, they can use, and then Feast will deal with the online portion for them. So we see that the data scientist as being a target user, but like you maybe have identified that this is more the domain of a data engineer. Like data engineers are the ones usually productionizing these systems. And so obviously data engineers do use Feast to save them time and do this in best practice way. But we actually what we envision are that data scientists are able to self-serve, put stuff in production using Feast. And we do see people do that. So that's kind of the goal with like the personas of people using Feast. So hopefully that makes sense. Cool. Yeah, so if there are any other questions, I'd be happy to take them. But hopefully this has been informative for you guys. Yeah, so as they're keeping trickling in, I'm going to keep answering them. But I think that's kind of like the formal end of the session. So like, if you guys, I'm going to keep answering the questions, but I think like, you know, I don't have any more material to go over with you guys. So, I mean, I appreciate everyone who did coming out. And I'll also just point you guys towards the right places to get involved with the project. So the GitHub, obviously, you know, we do their development on GitHub. So you can just see Feast Dev Feast, make an issue, you know, make my metrics go up. Then there's also the Slack as well. So you can join Slack by just going to the homepage, clicking here. There's usually pretty lively, a lot of questions being asked, and you know, people kind of chiming in to help each other out. So appreciate, you know, if you jump in Slack. We're always happy to talk to you. If you send me a DM on Slack, I'm even happy to like get on a call with you guys, and I can bring the other maintainer, Willem, who created the project, and we can like walk through your architecture and how you can use Feast. We're like super happy to do that. You know, it's always really insightful for us as well. So there's like, you know, open offer for you guys there. We also have like a Calendly link that is available somewhere in the docs you can use to book that. Let's see, I think it should be in community. We'll see. Yes, office hours. Here you go. There's office hour on Friday. Wow, I didn't know that. I think this is actually just a Calendly link you can use to book whatever time you prefer. So yeah, you can find that in the docs as well. So I think that's kind of where you can get help. And, you know, we're always happy to see more people try it out and, you know, unblock them where it makes sense. So appreciate, you know, definitely drop in. So as questions keep coming, I will keep answering them. So the lit asks, is transformation part of Feast? So right now, transformations are not a part of Feast. And by the way, I don't think this is like kind of like a thing that we're opposed to adding by any means. Like we have an issue on our roadmap called, you know, an issue on our roadmap where it kind of details some stuff about transformations that we do want to support. So on demand, or let's see, on demand, can we find demand? Transformations. Maybe I gotta search it. Transformation. Actually, quite an old issue, I believe. On-demand features. See, this is an issue where we're talking about implementing features that are computed at request time. So you can imagine if I go back to our example, like maybe in this get online features request, we also like send some information about the driver that we can compute into features as well. Like let's say we send the distance, the driver's location and the rider's location, and we can compute like a location that's the intersection of those two. So we actually we're not opposed to adding that type of transformation, for example. It's just that these pre-computed transformations, there's like a lot of scope there. It's actually like a very meaty issue. We don't have like the hands to do that right now. But we're definitely not opposed to doing that. And this is actually on the roadmap for the next 3 months. So we will support some type of transformations by then. So I will send this issue. If you scroll down to the bottom, you can see that this is open like now, and we're definitely actively discussing this. We removed the won't fix label because we're actually, this is something we're actively looking at. So that is something that you can take a look at, and that is something that is on the roadmap. But it's not something that like I don't think like we're gonna have materialized transformations in your warehouse or anything in the next couple of months. I just don't know if that will be on the roadmap. Although folks have asked for it quite a bit, and one of our larger users may be contributing it, but like absolutely zero promises there, just in terms of scope. Hopefully that is helpful. Now, the other thing on transformations I can add very quickly is Tecton, which is the company I work for, is like an enterprise feature store, right? And so, they do a lot of things that we do not do at Feast, just for scope. Like I think they're also just like an enterprise product, whereas we're like more focused on enabling engineers to like do really great work. So they have things like access controls in the product. So if that is like important to you, you can take a look at them. You can take a look at the product, and then also on the same hand, they have transformations inside of Tecton, and that actually significantly increases the amount of the footprint of the feature store, and also like the Feast, Tecton has like a scheduler built into it that will like run your transformations on a regular basis, whereas Feast doesn't have that. And that's just because like Feast is like more of a lightweight system. Like you saw me like spin it up, like pretty much you could follow the exact same steps I did, and it would be running on your cloud in like half an hour. Whereas in Tecton, you have to like it's larger, and you'd have to give us like a role ARN, and then like Tecton's like backend would spin it up on your cloud, and if there were any problems, someone would actually, like an engineer, would go take a look at it and make sure it's working properly. Whereas in Feast, it's just like a different kind of deployment model, and so we kind of opted for the footprint of the software to like not take this on it right now, though we're not opposed to doing it in the future. So Tecton does include transformations, and I can show you some of the transformations if you're curious. I don't want to pivot this whole section to becoming a Tecton demo because my voice is going to go hoarse by the end of it. But, for example, very similar definitions to Feast. This is a feature view definition where, see, as inputs, let's see. Oh, this is transformation, and then a feature view. Sorry, I believe that this is creating a feature. Let's go here. So this is a batch feature view. They also have streaming feature views, right? You see a lot of the same parameters that we have in Feast. There's also some metadata ones that I just didn't include for just because it makes that we didn't include in the quick start, but you can also add them. And then also it just appended to like a transformation definition, right? And so this is a SQL transformation that would run on a regular basis and compute that feature, and that would be registered in the feature store. So you could like fork this by just making a new file, and you could reuse it. And this one's actually scheduled, so there's a batch schedule of 1 day. So Tecton will run that every 1 day. So that's like how Tecton deals with transformations. But Feast just doesn't have this at the moment, if that makes sense. Cool. So hopefully that is like kind of some interesting background on you for transformations, and maybe even just like a sneak peek of where we're going to go in the future. Amit Sharma asks, can you please point me to some documentation on the API on how to add a new provider? Let's see if I can find it myself. Contribution guide. No, that doesn't work. Feature set. Let's see. So I'm just trying to find the right document, which might be a bit of a task because I don't have my bookmarks set up properly. Yeah, so I will have to just navigate to my Google Drive real quick to like find this. Let me just stop the share for now. I will find that, and then I will share my screen again, and I will send that link to you as well. So, content has been moved. I really should have like a bookmark for this. I literally like do this dance like once a week. Here. So this is a quick RFC, which I will share on public, so everyone can see it, on how to add a new on how to add just new stuff to Feast. So there's provider, offline store, online store. Also some stuff about plugins, some test stuff. I think this will eventually trickle down into documentation. I also think this is generally a bit light, like it doesn't explain what methods you need to implement or anything like that. So yeah, I think we're definitely looking to make this beefier. So I will keep you posted on that. But this is, I think, a starting point for you. And if you are like kind of seriously considering it, I think we're happy to get on a call with you when Willem has done pairing with some people who have like, wanted to do their own provider, like actually like kind of coding together. But yeah, so like kind of just like a bit sparse in the documentation there for sure. But hopefully going to fix that up very soon. Cool. The number of people watching has gone down and then gone back up. So if there are new people joining, put like a wave in the chat, and I wonder if we should do another, I can just talk about Feast for a bit because we're kind of like further in the session, and we've already kind of concluded the actual demo. But I think it might be helpful for you guys just to like ask some questions and give some general information before the session's over, which should be 20 more minutes. So is anyone new here? So Lalit is asking some great questions. Another one says, what would you say is the USP of Feast? So I will have to Google that term. USP, unique selling proposition. Yeah, so I say generally Feast is a feature store, and so kind of we follow kind of like the value propositions of what feature stores offer you. So I think there really isn't a better tool out on the market for productionizing your data for machine learning. There aren't tools that like help you kind of retrieve features and operationalize features and reuse features, which are, like, you guys know, are the most I'm sure you guys have experienced the fact that features are the hardest things to operationalize about. So I'll go to like another. I'll just end my sharing because we're not doing anything right now because I don't want to show you guys that inception thing. But features are definitely the hardest things to create in terms of, and labels as well, hardest assets to create for machine learning. And so dealing with the reuse of them, dealing with the sharing of them, dealing with the operationalization and helping data scientists push things to production without having like a data engineer tag along, definitely like the main benefit of Feast. But yeah, I think like it's kind of how we see it in terms of like other feature stores. Feast is definitely the lightest feature store to get started. We don't ask you to spin up any infrastructure like Kubernetes or anything. You can just like, pip install Feast and get started, which is definitely very helpful for like a lot of people. And and it's all Python based. So you can, if you need anything yourself, you can always just like make a contribution, which has like been very helpful for people to like. That's why we have so much activity around the project right now. Is that people just like kind of see a change they want and just dive into the Python code and they'll make the change. So yeah, like that's kind of how I see it. But I'm sure like people on my team would probably have a different answer if you ask them. Cool. So if there aren't any more questions, I'll probably end the session now, but I really appreciate everyone coming out. Again, always available in Slack. Hope to see some of you there if this session rung home. And we're always happy to chat to users synchronously or asynchronously or whatever you guys prefer. So hopefully this was great background for you guys, and really appreciate you guys coming out. Thanks, everybody. I'm going to leave now, and I don't know if that closes the session, but great talking to you all.